Hello guys, in this video we'll be learning about variable length encoding. What is variable length encoding? Encoding different symbols at different lengths is called variable length encoding. First, why variable length? Because we would like our encodings to use bits effectively. What is our main goal? When encoding data, we would like to match the length of the encoding to the information content of data. Fixed length encoding work well when all the possible choices have the same information content. In other words, all choices have equal probability of occurring. If the choices don't have the same information content, we can do better. By doing better, we mean that we can find encodings that have shorter expected length than a fixed length encoding. Ideally, we would like the expected length of encoding for xi to match the entropy value h of x, which is expected information content. We know that xi has a higher probability, that is has a smaller information content, so we would like to use shorter encodings. In general or in practical terms, higher probability, so the symbols having higher probability will have lesser information and shorter encodings. The symbols having lower probability will have more information and larger encodings. Let us see how. Take this example. You can see that B has higher probability 1 by 2 when compared to A, C and D, which has lesser information and shorter encoding. You can see that B, the length of B is 1 when compared to A, C and D. Length of B is really small, that is 1, whereas the length of A is 2, length of C and D is 3. Next, lower probability will have more information and larger encodings. You can see that C and D has lower probabilities, so it has larger encodings, where the length of C and D is 3, which is more compared to A and B. Let's try to encode BCA BAD. From the table, A is equals to 1 1, B is equals to 0, C is equals to 1 0 0 and D is equals to 1 0 1. So the encoding will be 0 1 0 0 1 1 0 1 1 0 1. So this is the graphical representation of encoding. This is the main root. As I told you, these 0 1 0 1s are all the branches of the binary tree, whereas B, C, D, A all are the leaves of the binary tree. Now let's try to decode back the encoded information using the graphical representation. We know that the encoded information is 0 1 0 0 1 1 0 1 1 1 0 1. First bit is 0, so we'll go back to the binary tree and start from the root. So this is the binary tree, and from the root it is 0, so we'll come back 0, so it's B. 1 0 0 1 0 0, so it is C. Every time you try to decode, you go back to the main root. This is really important point, guys. Double 1 from the root again, double 1, which is A. 0 again from the root, 0, which is B. Double 1 again from the root, double 1, A, and 1 0 1 from the root, 1 0 1, which is D. So the decoded information is BCA BAD. Now let us try to find the length of the encoding. We know that the length of encoding formula is summation pi into bi, where bi is equals to the length of the bits we are using here. In other words, the number of bits. Now the length, to find the length, it is 1 by 3 into 2 plus 1 by 2 into 1 plus 1 by 12 into 3 plus 1 by 12 into 3. This is how it looks. When you solve this, you get the length as 1.667 bits. Now let's try to calculate the entropy value. Entropy E or h of x is equals to log base 2 of n. When you calculate entropy, we get entropy as 1.626 bits. Oh, that's pretty close. We want our bits closer to entropy value every time. Otherwise, we'll be wasting a lot of bits. Now, expected length of 1000 symbols with fixed length encoding with 2 bits per symbol is equals to 2000 bits. With variable length encoding, it will be 1667 bits. With lower bound, that is entropy, it will be 1626 bits. Variable length is close to h of x but not exactly equal. Could another variable length encoding have done better? Let's try and see that. In general, it would be nice to have a systematic way to generate the best possible variable length code.